Alright, welcome back. After the point data tutorial, now we are going to create a line string tutorial. For this map again, I will use Budapest as an example, where I'm going to collect data from the Budapest Open Data Atlas, which is, by the way, in this case, relying on the local statistical office. So the data set I'm going to collect will show the total number of traffic accidents over the period of 2015 to 2019, and I will show you how to create an interactive map of Budapest, showing the most dangerous roads and allowing us to explore how dangerous different parts of the city are in terms of road traffic accidents. Let's see how the Python part works. First, let's have a look at the Budapest Open Data Atlas, which for now is only in Hungarian, but I'm sure you will be able to quickly translate it using any modern fancy LLM-based AI-powered language tools. So anyways, this is a very nice collection from the Atlo team, about roughly 50 different datasets covering the city of Budapest. It has a nice outline. It has a few remote sensing datasets. It has weather and climate. It has natural geography, including elevation, different water-related maps, and also land cover and even tree canopy. Then it also has a bunch of data about the social and demographic part of the city, from population grid to different more detailed statistics, such as the number of protests in a certain period or political polarization. There are also many other maps about human activity, from geographic or admin boundaries to real estate and housing data, as well as how the built-in area changed over the past few years. And the most interesting thing that we are going to visualize here in this map is going to be about traffic accidents. So for that, you will need to go for this one called Közúti balesetek. I will also add the download link in the code, so don't worry. Here you can directly go for the GeoJSON downloader or just copy the link, which I'm going to do now. And with that link copied, let's move on to the Python part. We are here in the Python part. I will also add the location we just copied. So this is the Google Drive link where you will find the traffic accident dataset. And this is the link for the overall Budapest Open Data portal. Again, sadly, Budapest doesn't have an official open data portal yet, but this collection, thanks to the team of Atlo, is a really nice one. So if you want to work with Budapest data, just go for it. After the necessary links, let's also do a few imports. GeoPandas, Folium, and Branca for a nice color map. And with these packages imported, we can already load in the data frame. Once it's loaded, let's have a quick look and see how many records we have. So this is going to be a citywide road network dataset. That's why we have more than 80,000 records. That means we have loads of line strings in this dataset. If we want to have a quick look, we can use the default plotter of GeoPandas. And here it is, that's still Budapest. And if you go back to the data frame, you will see that there is a median mean column which stores the average number of incidents in the period of 2015 to 2090 per road segment. Of course, the question may come, and you will see on the map as well, that road segments with higher traffic usually end up having more accidents, so it might make sense to normalize that by the number of vehicles observed there over this period, or any other indicator of road traffic levels. However, I don't really have that data at hand at the moment, and also at the end, the absolute number of accidents also matters, because that's the number of people who got injured. So here I think that we are fairly good to go with the absolute values. Then we will need to define the color map. So I'm going to color the road segments from green to red based on the number of accidents. So the more accidents reported, the closer we are to the color red. And to make it a bit easier to read, I will turn this into a discrete map with 10 different steps or layers. Then, as an additional preparation step, again, we will get the center of the map using the usual way, querying the bounds of the rephrase, querying the bounds of the input data frame, and then taking the mean of the coordinates of the bounds to get the center. And then let's go for the map right away. We define the map in Folium. We add the layers stored in GDF. We do some formatting tweaks by setting the line width and its opacity. And we also add the color map we just defined to use the coloring, and for that we will take the median mean column from the input data frame. Let's also add a few more lines. First, a simple legend to the color map, then the usual fitting to the screen command, and we can also save it for later and show the map on our screen. Now we will have a bright background, the CartoDB positron base map. This rendering may take a few seconds as well, because again we are visualizing nearly 100,000 line segments. But once the rendering is done, this is what we will have. So it fits my screen very nicely. This is the map of Budapest. It might look a bit chunky because we have relatively wide or thick line segments. However, as we keep zooming in, this will start to make a lot of sense. And if we zoom into the downtown part, you will see that there are these tiny roads which are completely green, which means that there are barely any accidents here, but also most of these have very negligible traffic, while the large transportation and traffic hubs like the ones here, they seem to have a lot of accidents. So this map can show us where problems can happen. For example, this road here is our primary shopping and walking street, so it's full of nice stores, restaurants, all that, and surprisingly it's also full of traffic accidents. So that's probably something for the people in charge to think about. And when we move on the map to these parts up in the hills, the hillside of the city, we will see barely any traffic incidents or accidents, maybe for example except here, which I would be very curious to see and hear why so much more dangerous than any other parts of this area. And by having said that, we arrived to the end of this tutorial. Remember, the code will be on Substack, and stay tuned for the next one.